Okay, so in a rural area, about 30% of wells that are drilled find an adequate water depth of 100 feet or less. A local man claims to be able to find water by dowsing, so he walks around with a stick, and apparently the stick shakes when he's over water, and he could tell when that happens. So you check with 80 of his customers and find 27 have wells less than 100 feet deep. What do you conclude about his claim? So we got to write appropriate hypothesis. Okay, so well, what is P here? And P is the proportion of wells successfully drilled by this, I'm going to call this guy, this dowser, whatever it is. Okay, so once we've defined P, then we can write that null hypothesis is that P equals 0.3, and the alternative hypothesis is that this guy can do a better job than that, and that would be that P is greater than 0.3. Okay, you can't just put down the null and the alternative hypothesis without defining P. You got to have what that equals. Okay. So our assumptions and conditions, okay? So we got the 10% condition, and in this case we're looking at 80 of his customers, so we're going to assume that 80 is less than 10%. Of all of his customers. Okay, let's see, random or representative. We're going to assume that the sample is representative, but it's not random, of all of his customers. Independent. We're going to assume that each customer is independent. And then the success failure condition. So what do? We checked 80 of them. So let's see, 80 times 0.3 is 24, and that's 24. That's greater than 10. And 80 times 0.7 is 56, and that's greater than 10. So we did all 4 conditions. Okay. And now we got to perform the mechanics of the test. Okay. So basically do a z-score, and we need to know what p hat is. So what is p hat here? Well, p hat is 27 over 80, and that comes out to 0.3375. So that's his probability of success based on our sample. So p hat minus p over the square root of pq over n. So 0.3375 minus p over square root of pq over n. Okay? And if you do that, you get 0.73. So that's our z, it's 0.73. So we're going to go, this is p equals 0.3, and that's a z-score of 0, and then a z of 0.73 is like right here. Okay, so this is z equals 0.73. So we got to figure out what that shaded area is. So we're going to go, we're going to say, okay, norm CDF from 0.73 to 99, and that's like 0.23. Okay, so that shaded region, that's our big P value, and that's 0.23. Okay. So part D says, explain carefully what this p-value means. Okay, well, what it means is if if the probability of success truly is 0.3, then there's a 23% chance that this guy will get a p hat of 0.3375 or higher. Okay, which means that that's not highly unlikely. Okay, generally in order for us to reject the null, it has to be below 0.05. So there really is no evidence here that this guy does better than any conventional method. Okay, because we can't reject the null, so there's no evidence that this is not 0.3. Okay, so that's basically our answer to E. Our answer to E is there is no evidence that this guy performs better than conventional methods. Be careful, you cannot say that there is evidence that this guy performs as well as conventional methods, because that would be accepting the null. All you can do is fail to reject the null. So all we could say is there's no evidence that this here, this alternative hypothesis, is true. Okay, so there's no evidence that his probability or his proportion of wills that he finds is greater than those of professional or conventional methods.